Hey, hello everyone. I'm David Coe, Senior Engineering Manager at SUSE. Today topic is Longhorn for your deployments. So this is the agenda. I will introduce what's a Longhorn and have a few demos to demonstrate Longhorn capability around the volume. So the first one is about Longhorn volume and its capability, like a volume type, access type, engine, replica, snapshot. And later, we will talk about the workload with Longhorn volume, with a different type of built-in Kubernetes workload can leverage Longhorn volume as its persistent volume source. And later, we have a volume knowledge, and we know how Longhorn volume works, and we can think about what kind of data service supported by Longhorn. So the first one is out of cluster backup and restore, and we will think about how to back up Longhorn volume to an external backup target, and also restore it back from the backup target. And later we will talk about in cluster because we have out of cluster backup restore. How about in cluster operation? So for Longhorn, we also provide the in cluster backup and restore, but we don't call it backup, we call it snapshot. So it's more like in cluster snapshot and restore. And lastly, I will introduce a little bit about what's new stuff introduced from Longhorn 137. Okay, so what's a Longhorn? Probably some of you already used Longhorn before, or maybe not. So I will let you know what's a Longhorn. So Longhorn basically is a highly available distributed persistent block storage, and we can call it soft-defined because everything just runs on top of Kubernetes. It is very light and reliable and easy to use. So even from the installation, upgrade, or even provide your non-disrupted operation during the upgrade or maintenance status. So how to deploy Longhorn? Basically Longhorn provides three ways. The first way you can deploy Longhorn from the raw manifest, even upgrade. And second, you can use a Rancher to install Longhorn from the Rancher marketplace. It will be very easy and very straightforward and easy to use intuitive user interface to let you operate Longhorn. The third is about the Longhorn upstream ham chart. So you can install the Longhorn from the artifact directly and even upgrade. So this installation way provide user a better operate Longhorn management. And also, of course, Longhorn as a persistent block storage system, the main purpose is serve the volume used by a workload running on top of Kubernetes cluster. So it definitely supports the persistent volume to any certified Kubernetes cluster, including major Kubernetes cluster. In 130, we will have a few enhancements and improvement for Longhorn running well on public cloud management Kubernetes cluster. So back to the persistent volume support, we support different type of volume access and different type of volume types and access type. So you can use a different way, like rewrite only and rewrite many, or even block device on file system. All of them Longhorn support. And also Longhorn based on the host file system to regard them as a Longhorn disk. So basically, he can run on top of any type of file system. But we strongly recommend EXT4 will be much mature and stable file system. No one can run it on top of it. But from the community feedback or from the user usage feedback, so basically Longhorn can run on any type of file system. And next one is about the backup because Longhorn not just provide volume capability, it also provides some data service functionality to enrich Longhorn different type of scenario and use case. So it provides a backup target. So that means you can back up your volume to an external backup target. So what type of a backup target we support? NFS or even S3 compatible interface storage we support. And let's talk about a Longhorn design. Longhorn actually based on Kubernetes. So we want to, based on the Kubernetes design pattern, to implement all the Longhorn functionalities. So including customer resource and control pattern. So we have a customer resource and you can operate it directly from 130. And also we have a controller to make sure that all the status of a customer resource can be reconciled to reach the correct uh, configuration of a resource we want to be on LAN B. And last one is about open source. Longhorn definitely is an open source project and have not just the contributor from SUSE Ranger and also have some contributor from external companies. And right now, we just graduated to an incubating project from end of last year. So it's getting popular more than before when it was a sandbox project. And right hand side is the slide we took is describe a little bit about the Longhorn architecture. So you will see the part request proceed volume, and Longhorn will create dynamically create engine process to represent it to for the volume. And actually, for downstream, you have a different replica. It's a real data set there in the replica to serve the volume. And replica is not just next to the engine; it can actually available in other nodes. So this Melon is a very highly available solution, like I mentioned the first item. Okay. Next, I will talk about some. I will have some demos and talk about long volume and workload with the long volume, out of class the backup restore and in class essential and restore. So let's take a look. So I prepared a Longhorn already. So here's a long system. So basically, you can use they have different functionality. You can check dashboard, nodes, and volume, and recurrent job, and backup, and even the whole settings or individual page for different functions. So here we focus on the workload and volume. So for volume, how to create. Generally, you can use the Kubernetes way because Longhorn supports dynamic provision, volume provision. So you can do the storage class and create a specific persistent volume claim. So Longhorn will dynamically create a persistent volume. But here I want to show a little bit. Actually, you can operate it, uh, do any functionality provided by the UI directly. So it will be the very similar experience, but better user experience for you from the UI perspective. So here, let's create a volume first. And all the attribute actually you can, if you operate on the storage cluster, you can set layer or even in for each volumes. But here I will create the volume from the UI first. So let's create test VOL. This is the volume name and specify the storage size. I just specify the small one because my cluster is for demonstration purpose. So I create a small one first. And later you can choose a different front end. Beside the broad device, actually, Longhorn can support iSCSI as like a server iSCSI target for external access. But here we focus on Kubernetes scenario. So broad device and data locality, you can make the replicas, your real volume data next to your volume engine. So on the same node, same disk, to make sure you have a better I/O performance. But of course, Longhorn is a distributed solution, so you can disable it to make the replica actually not definitely next to your engine. Or even you have many replicas, so it will be distributed in different nodes. So here I just choose the default setting, disable. And access mode, you can have a rewrite OS and rewrite many, depends on what your use case. And next one is back image. What's the back image actually? Back image is a raw device, raw image. So you can create back image by virtualization tools, create QCOW2 files. So actually, here's the file system inside. So you can save your old stuff data in your back image. And later, when you create a volume from Longhorn, you can just create the volume based on one back image. So when volume starts, the data in the back image will be easy in the volume. So it will be very beneficial for user if you want to use a back image as an intermediate data source for your volume you want to create. Okay, so replica auto rebalancing is more like a node. If you have a node down node Kubernetes restart, your replica probably will be fly around, reschedule around, and later when you node back or kubelet back. In the previous version, Longhorn did not support pull back or rebalance your replica in all the Longhorn disk. So you can enable this one and to have a different solution like a disable, disable, or even best ever. So when the node come back, we will try to rebalance your replica to available much the node a node with more disk space. So we will move the replica layer. Or division disable revision counter is more like a volume data replica data consistency. We will not we would discourage you disable that because it probably will make your data inconsistent, especially you have more than one replica. And next about this encryption, from Longhorn 1.2, we start to support the volume encryption. So you can use encryption and provide your secret to use that secret credential to encrypt your volume data. And that's why it's a no tag and disk tag. It's more like a disk or no selection. So you can specify, mention, I want to that my data to allocate or distribute it, create in specific node, specific disk, determined by node tag or disk tag. So this basic functionality is actually you can make your volume allocation or creation much efficient. So I just use the default behavior so we can just create. And after you create, at the beginning, the volume will just detach. And no, you have a default, you want to deploy a 3 replica. But until you attach the volume to a specific node, the replica will not create actually. So we need to attach it and it will make it happen. So that's back tab. And here you have a function menu. You can, before that, you want to change some body configuration. Before attachment, you still have a chance to change. But after attachment, the replica creation, created, you will have no way to create, modify some attributes like SS mode. So here we just attach. And because this is a demo cluster, we have two nodes here. So we just attach one of them and we will just start creation. And it will take some time. You see the two replica running, but what's going on the third one? Because at the beginning, Longhorn will not enable software anti-affinity allocation. So they mean the each replica of volume should not be located in the same node. So this is the default policy. You want to make sure your data is available. So even one node down, you still have data to other nodes. So this is the purpose. But again, this will not impact your behavior or function operation because we still support degrade mode. So you still have a two available replica here. So your volume will be have still functional. Okay, so we back to here. So what we want to tag is we create a volume and we want to write some data inside. So here, this is a test volume, and let me jump into the terminal. So here is a Longhorn repo. We have example folders here, several example here you can try. So here I just want to create a pod and write some data. So let's create pod first. And we can see the volume is a VOL. But wait, we did not create the persistent volume yet, right? Yes, exactly. So let's go back to the UI. Because you create the volume from the Longhorn UI, it is not uh, actually a dynamic volume provision. So you are responsible for create the PV and PVC if you want to reuse the volume in your Kubernetes workload. So let's create and let's try to use the same named PV tester volume and the SS mode. You cannot change because volume already attached. So PVC is the same and test volume and namespace we just specify default. And later you will see it's a bound, right? And everything, but it is not attached to a specific workload yet, but it's a bound. So let's go back. And we know the PVC is actually test volume. So we just need to change here. And this is very simple. We just launch your Nginx pods and we let the volume, test the volume attached to volume mount is a slash data. So after the pod running, we can go into the stage data to write some data there. Okay, and that's create the pods. And I use the terminal tool, Cat9S, so we can quick jump into the pod. Okay, so yep, pod is running. So let's just go into, and you will see the, yep, actually there's a data one here, and want to create data. Cast. Oh no, training. SUSECON to 2022 text. Okay, so we have the data inside. Perfect. So we have now, and let's just back to the UI patch. So we know about long volume. So later we create volume and we want to think about how to do the backup restore out of cluster backup restore. So Longhorn provider is a very basic function in Longhorn. So you can check your setting and we have a setting about a backup. So the setting is very simple. You just need to specify backup target. I have a backup target here. And you need to create a secret to describe your credential. Especially we are S3 compatible. It's about your key and security key. And yeah, it's a two credential layer you need to provide. And you can check the Longhorn documentation if you have no idea how to do that, because Longhorn documentation have described the detailed step. You just need to follow one by one. You can create. And here we have a recurring job. I did not introduce here, but I briefly talk about what it is. Recurring job can make you do a backup or snapshot, volume snapshot periodically according your schedule time. So, but any volume operation take effect, need to rely on the volumes actually getting attached. So if your volume detached, the periodical or recurring job will not work. So we need to allow the recurring job while volume is detached. So if you check this one, when we do a backup, recurring job backup, the volume will be automatic attached if it is detached status. Okay, so we set up the backup configuration. We go back to a volume, and here you can see the backup, and you can do the backup as well. Let's select. You can do backup. Go this one, and here we can do a backup. You can see backup page, and you can create backup here. So let's create backup, and also you can add some labels to your backup. When do any most of important volume operation like a backup, we would create a snapshot to make a snapshot for the volume and later create a backup on top of a snapshot. So you can make sure your data uh, protection and at that moment in your cluster, even outside of cluster. So every backup, you can take a look at backup page. There will backup volume is the same name as your backup your volume. You can click, you will see backup is external. So you will know, okay, the backup should be have a data, right? I write some file data in the stage data in the volume. So we can go back, but before that, I want to delete this volume so we can restore back from the backup target. So let me delete this simple part first so we can do another test later. Okay, this is test. Yes, indeed. But this is unmanaged parts, so the volume will be not deleted. So I need to delete here. Yeah, it just get detached because part is gone. But it will not be deleted because it's not a major part. So let's just delete manually. Okay. And PV and PVC will be gone as well. So right now the data is clean. And later I want to restore the data from the uh, backup target. So here you can choose which backup you want to restore and click the restore and specify your name, and we just use the same name. And we have tip, okay, if you use the same name and your following backup will fall into the same backup volume. That's fine, it's the same, right? In our demo. And also we can take this time to modify some specific, especially like a scheduling or your source want to a backup image. But this is not the case for us because we want the data from backup cell. Okay, let's just create. Okay, you will see the volume will be attached and retrieve the data from the remote backup target and pour the data back to the attached volume. Okay, so just get some time. Okay, so go to list. Maybe just a timing. Yeah, you can see it is attached right now because it just finished the backup restore and detach it because the status of volume is actually not attached, right? So it just detach. And later we want to create a PVC, the same. So we can reuse the part. We create a part later to check the data is actually inside or not. So we just create and we can just check again the simple part. Okay, so the source will be from here, the test volume. So we just apply again. Okay, you will see the volume getting attached. So the part is getting created. So we just wait it is created. So we ask it into to check data is there or not. Okay, it's running. Let's go into. So it should be have a data folder. Yep, SUSECON 2022 file is there. So it's good. Okay, so we delete the simple part. So we know how to create the volume and also do the volume backup and restore from and to the external cluster. And what's the next? The next is about the in-cluster snapshot and restore. But in-cluster snapshot and restore, how to do that? It's actually still we base on you can base on manifest, and to do that or use a UI. But use a manifest actually in-cluster backup snapshot and restore. We rely on the snapshotter. So what you need to do is actually you need to install the snapshotter first. So you can take a look at our documentation. We'll talk about the snapshot create setup. So here, and you need to install the external snapshot CRD. In our cluster, I already installed. You can choose one version, but remember, we have a precondition here. You need to use the same version of of CRD and corresponding snapshot controller. So the two things you need to install first. And after that, you can use the volume snapshot class to define the what type of a snapshot you want to create. In, in Longhorn, we support two types of snapshot. One is in-class snapshot. The other is external backup snapshot. So that means what I have done the demo for the volume backup restore, and you actually can do in the volume snapshot as well. I mean, through the CSI snapshotter. But so here I want to demonstrate is another case is about the type is in-class snapshot. So you have a volume snapshot, then you can trigger a snapshot to define a snapshot. You want to make a snapshot from which volume. So we have a volume test volume, so later we can make a snapshot from the test volume. And later, if you have a snapshot create, so you can restore a volume, create a volume from that snapshot. So let's get started. Again, we have a snapshot example here. So I want to let you know you need to create a snapshot cluster first. So we define it here, and I don't want to do this backup because I have done before. So the UI, and right now I want to use a snapshot cluster with a snapshot in cluster snapshot to let you know how to create snapshot, how to restore the volume from a specific snapshot. So let's create a snapshot cluster first. Okay, perfect. We create. So the next, we need to provide a PVC to that we create snapshot from a specific volume. So let's have a volume test volume. Go back to the UI first, and we need to make it attach because when doing a snapshot, this is a precondition. We need to make it attach first. So let me, if you want to do a snapshot, you can snapshot from a live volume, and this is the way to do. So the volume is the test volume, and we can continue to do this one. Snapshot PVC. Okay, so you will be have a snapshot, volume snapshot, volume snapshot. Okay, so we have a volume snapshot here. Very good. So that means we have a snapshot, and we can take a look this volume. There should be have a snapshot here. So we will see we can restore from that snapshot. And we remember the volumes actually have one data inside. It's the SUSECON, SUSECON.txt. Yes, exactly. So we will restore from there. Okay, let me check. We have an example here, snapshot. Still snapshot. PVC. And we have another name is the test volume snapshot. Test restore snapshot PVC. So we will see how to create and use it. But it's actually the size is different. Just 1 megabyte. So if you specify wrong snapshot size, volume size, you will not be created. So we just have to restore PVC, and then we can go into to see the volumes. Yeah, we have restored, and we will see the volume is getting attached. Oh, request size is different. Volume snapshot. Okay. So that means we have a wrong size here. This one. Yes. Yes. And let's see. Snapshot. PVC and test snapshot here. Yeah. So let's create again snapshot PVC. Okay, it should be created. And source is test volume and resource size is 1. And let's describe a bit. Okay, the snapshot should be ready. Okay, we have a snapshot here. Perfect. And later we try again to restore the PVC and just double check the size is correct. The sum of the source volume 1 megabyte. And that we have restored. If you see it, check again. We have PVC here. And let's just use it. Yep, here's the bounding. So that's great. So we can see the test volume is restore volume is here, and we just want to check the data is really there, right? So let's go back to let's deploy this one and use a different test volume. Apply again. Just wait, running. So we change to pot. We will see a little bit until it's running. We can access into. Okay, perfect. It's running, and we can see the data is there. SUSECON to 2022. Okay, perfect. So let's go back to the slide. Okay, so we know about long volume and volume access and engine replica snapshot. We also talk about how you can use your workload to with your long volume, right? Of course, you can create your deployment of step set and specify your persistent volume claim, or when you use a step set, you can use a volume claim template to make it happen. And all of the same, the flow is actually the same. You just specify the PVC and create a PV by Longhorn and make it bonding together, and your workload will show up together with the workload. And also we talk about out of cluster backup restore. So you can backup your volume data to an external backup target and also restore the backup back from a remote backup target to create a new volume. And besides the out of cluster backup restore, we also have an in-cluster snapshot and restore. You can use a CSI snapshotter and the snapshot cluster class and volume snapshot and create a volume snapshot content. So you can restore the volume from a specific volume snapshot. So it's about in cluster. So this is a basic functionality provided for Longhorn volume. So that means you can have a different combination and capability for your flexibility, for your to provide flexibility for you to measure your workload volume. Okay, before finish the session, I want to just show some new stuff will be introduced from the Longhorn 130. And from 1.0, we will introduce the resource version V1 Beta 2. So we have a more, together with the automation webhook, including mutating, and validation, and also conversion webhook to provide some compatibility between the V1 Beta 1 and V1 Beta 2 resource. And next one, we have a storage network. So for the current version, long version, all the network, all the traffic, including the control traffic, data traffic, all run on top of cluster network. Later, from the 1.3.0, we will you can have a function feature. You can segregate your network between the control plane and network plane based on modules. So you can make sure you can complete utilize your specific interface for the data plane to provide better function, better probability for your uh, volume I/O data I/O. And next about the public cloud management Kubernetes cluster support. Of course, Longhorn can run on any certified Kubernetes. But for public cloud, sometimes user will encounter some class auto scaling issue or even about no pool management, like a replacement or even upgrade. And from 130, we already provide one experimental feature to make sure the two major requirements get resolved in 130. And next about the snapshot purge. Longhorn volume is based on snapshot concept. So that means that even your volume size is 1 GB or 20 GB, right? Because you have snapshot, so your actual size is more than that. So we want to set. So in one year we improve the snapshot purge a little bit to make sure user can purge your volume, your first snapshot behind the volume hat to save your space more. So this is about the snapshot purge. In console auto scaling, like I say, you can install the upstream Kubernetes upstream console auto scaling component to make sure you can scale out, and scale up and scale down. So this is a way to that you scale your number of node in your cluster. And CSI snapshot for Longhorn snapshot, yeah, we have a support. Longhorn snapshot, we support the CSI snapshot before for the backup, but as you see in my demos, we actually support CSI snapshot for Longhorn snapshot in cluster snapshot from 130, because the demo I use a version 130 RC1, so you can see the functionalities. And that's about backing image. Backing image we provide some function before 130, like a backing image upload or backing image download from external website or destination, and even you can create a backing image from a volume. And in 130, we want to make the functionality of backing image much complete. So we will provide backing image download. That means you can download backing image from Longhorn UI or even from API, a RESTful API. And that means user can leverage back image as is the maintenance tool. Like you want to have offline backup, and you can make your volume, create your volume, create a back image for a specific volume, and download that back image. And next one is about secure community communication among the control and data plane components. So we introduce MTLS for the data plane and control plane. Make sure your traffic communication, even in cars, is much secure. And this function is actually disabled by default because you need to provide the MTLS information, credential, certification information. So when you provide that, our component will based on that provide MTLS communication. And upgrade path enhancement, we enhance a little bit, provide some version fielding, so you will make our upgrade path more efficiently and speed than previous versions. And often replica cleanup is the very important features and request from the community user, because sometimes you have a no maintenance and some replica is not actually active anymore, not belong to any volume. And when we reuse that node back, the replica will be stay there even is not actually used actively. We call it open data, open replica. In one level, we have an open replica cleanup. You can clean up by yourself. We will identify how many open replica in your cluster, and you can operate them from the Longhorn UI or even from the open Longhorn customer resource. And also, we have a function you can enable. If by default is disabled, you can enable to do automatic open replica cleanup. So it will be beneficial to save or free your storage space if they are occupied by open replicas. And this one, that's not least, is about the S390X architecture support. This is a new one we introduced. The previous experimental architecture support is ARM64, and this time in 1.0 we want to introduce S390X. So this is very cool because we have another new architecture support in Longhorn. Okay, I think that's it. For 1.3 there are actually more items, but I don't have enough time to share here. I would encourage you to try it and give us feedback because as a Longhorn team, we always want to know more feedback from users, even any kind of user, community user or customers. So this is what we want to hear. Your feedback is very important for us. Okay, I think that's it. And thanks for your listening and see you next time. Bye.